Okay,
Visible.
okay, sir. Good evening. Our project topic is weather monitoring and prediction system for farmers, and we are guided by Professor Anas MM. These are the content of the presentation. Going straight to the introduction. Uh, we all know that weather change such as irregularities in rain, heavy summer rain, flood, heavy wind, etc., is affecting the agricultural sector. And to study and implement our idea as a project, we select Wayanad as a place. As we know that micro level climate of Wayanad is seeing considerable change in last few years, which is a threat to agricultural sector. As a reason, mainly the rain flood crops, which is more in Wayanad, facing low productivity, low quality, and overall destruction. Banana, vegetables, rubber, coconut, arakan, etc. are the crops which are affected more. To give a clarity, almost 2,12,000 banana plantation hectares in hectares have been uprooted in last year's summer rain and heavy wind. The Agromet Department of Indian Meteorological Department have done proper research in this matter and put forward some preventive measures. But these results are not reaching most of the farmers in local communities. And to solve this problem, a mobile application is developed where both weather forecasting and crop advisory are displayed to farmers. We all know that weather plays an important role in our farming system. For better production and maintenance, it is important to monitor weather. Along with weather monitoring, it is imperative for farmers to do necessary maintenance, such as watering, adding fertilizers, and prevention of diseases emerging from weather changes. Access to short-term weather forecast and seasonal forecast are still limited in local communities of Kerala. Farmers can't fight the weather, however, he can adopt the given situation and take additional farm management practices to minimize losses. This project is developed for forecasting weather parameters like temperature, humidity, rainfall, wind speed, etc., and provide accurate information regarding the management of crops, such as watering, adding fertilizers, warning system for farmers, etc. In this project, a mobile application is developed for farmers and weather forecasting and
ബാക്കി ഉള്ള അക്ഷയുടെ മൈക്രോഫോൺ ഓഫ് ചെയ്യായിരുന്നെങ്കിൽ എക്കോ വരില്ലായിരുന്നു.
uh,
Okay.
shall I continue?
Yes. Yeah.
Okay, thanks. So farmers can select their crops uh, to know preventive measures that should be taken to cope up with weather changes. Using the system, farmers can increase their productivity without much loss. They don't have to depend upon many platforms to gather information. Our project is all-in-one assistant for farmers. And in case of Agromet advisory services, the source of weather and climate-related risk in agriculture are numerous and diverse. Limited water resources, drought, desertification, land degradation, erosion, flooding, early frost, and many more are such risks. Effective weather and climate information and advisory services together can inform the decision making of farmers and improve their management of related agricultural risk. And to predict the weather, we are using the LSTM model. As name suggests, long short-term memory. It is a machine learning model used for memory purpose. That is, if we give past, it will predict future, mainly um, in case of weather. In using LSTM, you can set the n timestamp, the number of timestamp. In our case, it can be days or hours, and it can be used as input for prediction. This is important since we want to consider how much data should be our model check out before making a prediction. This depends on the application. Let's say if we want to do temperature or rainfall prediction, then we might need at least some months or years of data to predict the next day's data. The more the data, the more the accurate the prediction is. Thank you. Sorry. In our system, it is divided into two parts, that is hardware part and software part. In hardware part, we have sensors to collect real-time weather data. This data is stored in a cloud platform. We are using Amazon Web Services and through IoT platform. Here we are using ESP32 board, and from the available data, we train our LSTM model to predict the future outcomes. In the end, both weather forecasting and crop advisory are displayed to farmers through our mobile application. Okay, Nabita.
Akshay, presentation. Okay, hardware components. So first one is ESP32. So ESP32 is an open source development board designed for low power IoT applications. And here the NODMCU is used for sending the data for data collected by the sensor to the server. And it has an extensor dual core processor having 32-bit microprocessor operating at 240 megahertz, and it needs 3.3 volt power supply, and it has a 512 KB of RAM, and it uses SPI and I2C communication protocol for transmitting the data, and there are 18 channels for ADC pins and 2 channels for DAC pins, and it comes up with the built-in Wi-Fi and a Bluetooth. Next one is DHT22. DHT22 is a digital humidity and temperature sensor. Mainly it consists of three components, that is humidity sensing part, temperature sensing part, and an 8-bit microcontroller IC. Humidity sensing part contains two electrodes separated by a substrate. So it measures humidity like when humidity changes, the conductivity of the substrate changes. That changes the resistance between two electrodes, and this resistance can be measured and processed by the IC. Similarly, the temperature sensor here we are using, it's a thermistor which measures, it is a variable resistor that the resistance is varies with the varying temperature, and it has a power supply of 3.3 volt to 6 volt DC, and operating range for humidity 0 to 100% RH, and temperature minus 40 to 80 degrees Celsius. It has an accuracy of plus or minus 2% for humidity and plus or minus 0.2 degrees Celsius for temperature. Next one is BME280. BME280 is a combined digital humidity, temperature, and pressure sensor. And these precise sensors can measure humidity from 0 to 100% with plus or minus 3% accuracy, and pressure ranges from 300 to 1100 hectopascal with a plus or minus 1 hectopascal accuracy. Temperature ranges from minus 40 to 85 degrees Celsius with a plus or minus 1 degree Celsius accuracy. And need a power supply of 3.3 to 5 volt, and it uses ISP and I2C communication protocol. And there are separate pin for SPI and I2C in BME280. Next one is rain gauge. The figure shows is the tipping bucket rain gauge, and it consists mainly a funnel, two tipping buckets, a switch, and a reservoir. And the funnel receives when the rain is collected through the funnel in one of the tipping bucket, and when the one of the tipping bucket and the rain collected reaches to 0.25 millimeter, the bucket tips into the reservoir, and brings back the second bucket to the position under the funnel, and it continues the process. And for each trigger, a switch is activated, which is an electric circuit to transmit the count. And next one is anemometer. Anemometer is an meteorological instrument that used to measure the wind speed and direction. And there are many type of anemometers. Here we are using cup anemometers. It consists of 3 or 4 cups attached with a horizontal arm, and which is attached with a vertical rod. So it measures wind speed, like when wind blows, the cup starts to rotate, and that makes the rod spin. So when the stronger the wind, the faster the rod spins, and it calculates the wind by counting the number of rotations made by the anemometer. Next one is capacity soil moisture sensor. The capacity soil moisture sensor, it is similar to a capacitor. It consists of two metal plates separated by a dielectric medium. It doesn't measure the moisture directly. It measures the change in capacitance caused by change in dielectric medium, and the measured capacitance is converted to a corresponding voltage using a 555 circuit, and an ADC is used to convert the final output in a digital form, and it has an operating voltage of 3.3 to 5.5 volt. And final one is BH1750. It is an digital ambient light intensity sensor, and that senses the light intensity. So the sensor containing a photodiode, and the photodiode consists of a PN junction. So it works like when light falls on the photodiode. When light falls on the photodiode, an electron hole is created in the depletion region of the PN junction, and due to the photoelectric effect, an electricity is produced in the photodiode. So the produced electricity is proportional to the intensity of the light. So we use an op-amp to convert the produced electricity into corresponding voltage, and an ADC is used to convert the final output into in a digital value. So I2C communication is mainly used for transmitting the data. It has a supply voltage of 2.4 to 3.6 volt, and measurement range of 0 to 65,535 lux. Software part will be taken by.
In the software section, we have three main stages: real-time weather data collection, uh, training, training and deploying the deep learning model, and providing the final output to the user interface. In real-time data collection, the node MCU and the sensors are wired up and connected to a nearby internet-enabled access point. The sensor values are then sent to the cloud server by the node MCU. At the server, the data is validated and stored in the serverless database. In deep learning, it has training and testing stages. The training stage covers 80% of the dataset, and testing covers remaining 20%. LSTM network is used in here for training the model. The output graph represents the prediction made by the model over the testing dataset. On comparison with the real value and predicted value, the error is between 5 to 20%. The trained model is then deployed to the cloud server. In the user interface, the Android app consists of two main parts. The first screen relates about the weather conditions and the conditions for the crop for the present day, the next day, and for the next week. The second screen consists of crop advisory. It is displayed on selecting the crop from the first screen. According to the condition, the relevant crop advisory is provided to the client. These are the screenshots of the app interface.
And this is our total cost of the our project weather monitoring and prediction system. It's all around 22,475 rupees in the rupees. And going to the next slide. Coming to the conclusion of our project, our weather prediction and monitoring system improves the crop quality, crop production, and also reduces the destruction of the crops. Our system analyzes the data from the sensors, and predictions are made through the deep learning. These predictions are given in the applications that are provided for the farmers. This application acts as an assistant for them by advising them with the techniques to be adopted, so that the farmers can understand the upcoming changes and do the necessary things before it gets late. So the farmers can able to so it will help him to understand the upcoming changes, so he can improve his yield and also improve his crop production without that much of struggle. And finally, by implementing our system, it will reduce the gap between the farmers and authority, and also our system will help him to produce a good yield even if he doesn't have that much of knowledge about the cultivation. That's all about the conclusion, and going to the future scope. These are the future scope of system. And first of all, data. Nowadays, the importance of the data is increasing day by day. So we are collecting the real-time data from the sensors and storing it. This collected data obtained from the system can be used for the several other purposes. And the next one is by using our system, the farmers can understand the upcoming changes and do the necessary precautions or do the necessary action. And finally, as I said before, the farmers need not to depend upon the any other authority. Okay, then going to the next slide. These are the references that we are going through this project, and these are the references. And thank you.
So reference format is not correct.
Okay, sir.
You can search any conference or journal papers. Then you can have, say, a format for the reference.
Okay, sir.
Okay.
Okay. So even though you are using many sensors in your system, how you calibrate your sensors? Because capacity sensor you are using, how you calibrate
Okay,
Dep-
we went to
depending on our
IMD. Okay, sir.
weather, Wayanad weather conditions.
Yes, we went to IMD to ask about this, and we calibrate our system with reference to their system. And that time they told us that they will help us to calibrate our model with a reference to their system, their weather station.
Okay, okay. So your
Okay, and
system
also it
is
needs some
calibrate.
expertise solutions. We as engineering students can't calibrate this alone. They said that. So we need experts to
Okay,
calibrate according to the places.
okay, okay. Next, Gabit. Any more?
Yeah, can you just show me the implementation part? You have shown some implementation detail
Yes.
around 22,000 rupees. Can you show me that part?
Sir, we haven't done hardware part yet. It's an estimation cost as
Yeah, can you show me just show plan?
what, sir?
This one. Yeah, this one only. Yeah,
Okay.
the total cost. So, so here, you are placing only one DAT, one BME, one moisture sensor. Everything is single piece or different pieces. So, in what way you are going to implement the system?
You mean the weather station?
Yeah, basically the soil moisture sensor means how many moisture sensor you will use to analyze the agricultural field.
Because it required multiple array of sensor is required.
Yes.
What is the
We are
exact
using
planning?
only two, not more than two. We discussed and
Oh,
agreed
okay.
upon using two sensors.
So only two moisture sensor is enough to analyze the total agricultural land.
Not total, sir. We are placing at
Uh,
one point. Our station is placing at one point,
okay.
and we agreed upon to use two sensors to analyze.
Okay. But so how will you select that a single point in a agricultural domain? Is there any selection criteria?
At first, thought about that, asking the farmers.
Okay.
Okay, that will be more useful. They know their land, and we thought upon that.
Okay. So be clear with the implementation step. Means how you will implement in a real life. I think this cost is you can. It's not correct. I think many things are perfect, but this implementation thing I don't have much idea how you are going to implement.
Okay, sir.
Um, and this ESP32 is system on chip, right? It's not just a processor. I think
Yes.
it's a
Okay.
system on chip.
Yes, yes.
Okay.
Can you show any demonstration?
Videos,
Okay, sir.
demo
Actually,
videos.
show that mobile application.
Sir, is it visible?
Okay, no, okay, okay, no.
Okay, sir. Sir, this is today's data. Uh, in today's data, it is showing good condition for ginger and rice. And this is tomorrow's data. We are showing temperature and rainfall is not showing now. Okay. Based on tomorrow's data, the good condition is for banana and rice. If we select that, we can see the crop advisory. For banana, watering is we got adequate rainfall, so no need to provide more watering, and we should do proper drainage controlled irrigation. And in the case of rice, adequate rainfall is received, and it is land preparation stage for rice, seedling stage, so fertilizer is not required as of now. And this condition, in this condition, it is bad for vegetables, as there's a chance for leaf rust disease for coffee. So Bordeaux mixture should be sprayed. Case of vegetables, this condition, the main pest attacks are plant hoppers, fruit flies, etc. So measures against that should be taken, like setting up of fruit taps. Then this is next week's prediction. For next week, it is showing that banana, ginger, and rice have good weather conditions, and bad condition for coffee. As rainwater shouldn't be stagnant in coffee plantation, the proper drainage should be provided. Okay, anything more? And
Okay.
We are presenting computer vision for autonomous vehicle using machine learning and deep learning methods. The group members are Ashwani, Prabhu, Shahina Siti. Our project is graded by Anas Chandam, Assistant Professor BBC Wayanad. Overview, introduction, literature survey, limitation, problem statement, hardware requirement, software requirement, pattern detection, work done results, and discussion, references.
Slides come.
The major part of autonomous vehicle solution, image detection is part of computer vision and a process to identify and detect an object in a video or image. And we can understand the of autonomous vehicle during this pandemic because it's very helpful to use autonomous vehicle in these kind of conditions. Many researchers are going on in this area in autonomous vehicle because high risk situation, this is crowded area. Methods to detect images. AI is a broad discipline. ML is the subset of AI and defined as really ML but applied to literature survey because we are using and evaluation of CNN. And in this method, we have sign detection with a different resolution. Introduced by Ying Chi Chu and Hu Lun. It is a machine approach in this section for autonomous land verification, Raspberry Pi. This method they are using they're using a structure like that video capture convert with RGB to HSV and find contours. If the contour is greater than 0, then the system is going to decode contours. If you're finding a larger section and show it on the image, then the section on the image is valid to table. In this case, here they have so many classification. They have so many classification like SPM, SPM, loads, etc. Here they are proposing some system some method to improving the future score that is merged region algorithm. Then object detection with deep learning review. This is another one. Gain a complete image understanding. We should not only concentrate on classifying different images, but also try to precisely estimate the context and location contained in the image. Limitations. We cannot follow a method, a single method to apply on computer vision, because we have to adopt some extracts from each method for developing the system. If many analyses are going on this field, the system will be developed platform. One statement, lot of research are going on for developing effective autonomous vehicle for proper working of an autonomous vehicle. There are so many techniques available. In our case, we are studying methods and implementing S1 for detecting pedestrian, detecting traffic sign, traffic light, and detecting vehicles. Will explain the name.
In our method, we have a Raspberry Pi camera and a monitor. We have two part, training part and testing part. In training part, we made a model. Input from the camera can compare with the model, and then we can predict the output can be seen in the monitor. Other we are Raspberry Pi as our processor. It has 4 gigahertz, 400 megahertz video for IV. We have a 1 DDR 900 RAM.
ടോട്ടലി എക്കോയിങ് ആണല്ലോ ടോട്ടലി. പ്രസന്റ് ചെയ്യാത്തൊരു മൈക്രോഫോൺ ഓഫ് ചെയ്ത് വെക്കായിരുന്നെങ്കിൽ എക്കോ വരില്ലായിരുന്നു.
In Raspberry Pi 3, we have a 4 USB ports. Also support the video. The video output is HDMI and composite video. And network speed is 10 by 100 MB per second. Ethernet and 802.11 nano wireless LAN. And here we are using a stereo camera. Is the type of camera with 2 or more lenses with a separate image sensor or film pair for each lens. And stereo camera can be used to making stereo views and 3D pictures. The distance between the lenses in a typical stereo camera is about the distance between one's eyes and about 6.35 centimeter. In stereo camera has high distance accuracy of near objects, and the stereo can be used for collecting 3D images. In the case of vehicle detection, we want the 3D images. The software requirements. Here we are using Python as our programming language. It's an object-oriented programming language. It can support graphical user interface and easy to learn. We have a large standard libraries. Then we are using OpenCV. It's a cross-platform library. It can develop a real-time computer vision application. It's an open source library, fast speed and fast prototype, easy to integrate. And we are using TensorFlow software. It is a free and open source software. Library for it has a library for data flow and differentiable programming across a range of tasks. It is developed by Google Brain team. It is a symbolic math library and also used for machine learning applications such as neural networks. The Keras is high-level interface to TensorFlow. It's an open source neural network library. The user-friendly modulator is running on the top of TensorFlow. It is developed by part of the project near it is the de facto standard package management system used to install and manage the software packages written in the Python. Most of the versions of Python come with the pip installed. Traffic sign detection. Localization is the detection and localized where an input image or frame a traffic sign. Recognition takes the localization image and actually recognize and classify the traffic sign. In our project, we are taking the German dataset. It contains 48 sign of dataset, but we try in the training of this program. We can it need a lot of and the processing time was very high, so we cannot use this old data set. So we selected 21 signs in this data set and convert the and resizing the data set to 32 into 32 pixels and the converting the color images into gray images. For making more number of models, we use the shifting and flip property. By using shifting and flip, we can improve the number of models. Then the input image is compared to the training model. We can predict the output. In this project, we get a 98% of accuracy. This is the graph. This is the output graph. It shows the low accuracy versus approach. In this graph, we can see that the validation is less validation. We get more accuracy. And it is the video simulation of sign detection.
Then next is the pedestrian detection. The pedestrian detection is done similar manner of the traffic sign detection.
Mega microphone.
Okay.
Here the pedestrian detection is done in a similar manner of the traffic sign detection. Here first we train our model. For this, we load our training and testing state from our dataset, then pre-process the image and train our model. Then we serialize our model to disks, so we can later use it to make prediction of one new data. Then our system divides the input image into a number of grids. If the center of an object falls into a grid, that grid cell is responsible for detecting the object. Each grid cell predicts an bounding box and confidence score for these boxes. Confidence score reflects how confident model is that box contains an object and also how accurate it is. Then for prediction, we load the model from the disk and load the sample image from the disk and pre-process the sample image in the same manner as we did for training. And then pass our image through our image classifier and obtain our final prediction. By doing the pedestrian detection, we get about 99% accuracy. The video. Then next is the traffic light detection. In traffic sign detection also, training is done in a similar manner. For traffic light detection, when traffic light is on, its corresponding color component is much bigger than the other color in RGB color space. According to this feature, red, green, and yellow color pixel of a traffic light can be extracted by subtraction between two color components. That is, when the green light is on, G component is bigger than R and B components. Similarly, red traffic light is on, the R component is bigger than the G and B component. Then the object extraction is done by as follows. If x minus rg is greater than tr and x minus r xr minus xp is greater than tr, then xr will be 255 and xg and xb are 0. And if xg minus xr is greater than or equal to tg and xg minus xp greater than or equal to tg, then xr equal to 0, xg equal to 255 and xb equal to 0. Where tr, tb are the threshold values. If the conditions are met, the corresponding pixel is purified for color segmentation and other pixels are set to white colors. This is the plot we get. It shows about 96.14% of accuracy. Then RCNN and fast RCNN use selective search to find out the region proposal. Instead of that, we use convolutional feature map and reshape it in the size of our concerns, then predict the class of our proposed region. In case of fast RCN convolution operation, runs once per image and feature map. Then in fast RCN convolution operation, done once per image and feature map is generated from it. In YOLO, a single convolution network predicts the bounding box and class probabilities for those boxes. Next, we are coming to work done.
Sahina, no voice.
The slide moving. Next is the work done. This is the work done so far by us. Next is the result and detection. So it's total code. Coming to result, we know there is no straight answer for which the model is best. So we have to conclude that from each of our studies, according to the field of application, the accuracy of fast RCN is about 84.5%, and for faster RCN is about 86.6%, and for YOLO it's about 92.22%. Then coming to conclusion, we find that no method is 100% suited for vision of autonomous vehicle. The new technology will stand over the old, but we can prefer the best one according to the application. So we need to train our data set to improve the accuracy. Here we implement the method which is more accurate than the method of our studies, and these are references. Thank you, sir.
I think now you can show the demonstration videos.
Yeah.
ഇല്ലില്ല സിംഗിൾ പൊസിഷനിൽ തന്നെ നിൽക്കുകയാണ്. ഇപ്പൊ ചെറുതായിട്ട് മൂവ്മെന്റ്സ് വിസിബിൾ ആണ്, പിന്നെയും പോയി.
അടുത്ത വീഡിയോ പ്ലേ ആയിക്കോട്ടെ. റേഞ്ചും കുറവായി ഇവിടെ. സാർ അടുത്ത പ്ലേ ആക്കട്ടെ.
ഓക്കെ ഓക്കെ.
ചാർജ് കുറവാണ്, അതാണ് കാര്യം.
കറണ്ട് ഇരിക്കുന്നില്ല.
അതുകൊണ്ടാണ് ചൂടാവുന്നത്.
ഓക്കെ.
സാർ ഇത് കാണാൻ പറ്റിയിരുന്നോ?
ഇല്ല,
ഞാൻ പ്ലേ ആക്കിണ്ടായിരുന്നു.
വേറെ ആർക്കെങ്കിലും പറ്റില്ല ഇത് റൺ ചെയ്യാൻ?
അത് സാർ PPT ഉണ്ടാക്കിയ ആ ഫോൾഡറിൽ തന്നെ വേണമെന്ന് പറഞ്ഞിട്ട് അപ്പൊ ഞാൻ എന്റെ കയ്യിലായിരുന്നു എടുക്കുന്നത്.
ഒരു കാര്യം ചെയ്യാമോ, എനിക്ക് ഈ ഒരു വീഡിയോ യൂട്യൂബിൽ അപ്ലോഡ് ചെയ്തിട്ട് എന്റെ ലിങ്ക് ഒന്ന് അയക്കാമോ? അപ്പൊ ഞങ്ങൾക്ക് സെപ്പറേറ്റ് ഒന്ന് നോക്കായിരുന്നു.
ഓക്കെ സാർ. ശരി
ലുബൈബ് സാറേ.
അത് മതി.
യൂട്യൂബിൽ അപ്ലോഡ് ചെയ്തിട്ട് വീഡിയോ ലിങ്ക് അയക്കാനല്ലേ?
യൂട്യൂബ് ലിങ്ക് അയക്കാം. അപ്പൊ ഞങ്ങൾക്ക് അത് നോക്കി നമുക്ക് ഇഷ്ടമുള്ള സമയത്ത് നോക്കി വാലുവേറ്റ് ചെയ്യാമല്ലോ.
ഓക്കെ.
Then some of the suggestions mention ചെയ്യാനുണ്ട്. One is in earlier slide. Can you hear it? Earlier slide, it is starting slides. It say that it is the limitation. So in beginning, you say that it is a limitation. Don't say like that. It's a background of your work. Background of your project. Okay. Don't say that it is a limit. If you say like that, it is the limitation of your work. Okay. And how you find the accuracy of 3 different methods? How many samples you taken?
Question മനസ്സിലായില്ലേ?
You can answer that. No need of showing the slide. Meha, Shahana.
43 ഡാറ്റാ സെറ്റ് ആയിരുന്നു. അപ്പം അതിൽ നിന്ന് നമുക്ക് അത്രയും പ്രോസസ്സ് ചെയ്യാൻ പറ്റാത്തത് കൊണ്ട് നമ്മൾ കുറച്ചെണ്ണം എടുത്തിട്ട് അതിനെ വെച്ചിട്ട് ചെയ്തത്.
Number we need number.
അപ്പൊ നമ്മള് 10 ഡാറ്റാസ് വെച്ചിട്ട് ചെയ്തത്. 10 ഡാറ്റാനെ ക്ലിക്ക് ചെയ്തിട്ട് നമ്മള് കുറച്ച് ഇമേജസ് ഓരോരോ എന്താ പറയാ.
When you're taking 10 numbers, how you say that it is 92%? You're taking 10 numbers 90, 80 like that.
10 ഡാറ്റാ സെറ്റ്സ് ആണ് എടുത്തത്. എന്ന് വെച്ചാൽ ഇപ്പൊ സയൻസ് 10 എണ്ണം അങ്ങനെ എടുത്തു. എന്നിട്ട് ഇപ്പൊ നമുക്ക് ട്രെയിനിങ് ഇമേജസ് ഇപ്പൊ 100 എണ്ണം ഉണ്ടെങ്കിൽ അതിൽ ട്രെയിൻ ചെയ്യിച്ചു.
അശ്വിനി, മേഘ, ഷഹീന.
ഓക്കെ സാർ. അതില് നമ്മളിപ്പം 100 ഇമേജസ് ഉണ്ടെങ്കിൽ അതിന്റെ അകത്ത് ഇപ്പം എന്താ പറയാ ഒരു 70 എണ്ണം വെച്ച് നമ്മൾ ട്രെയിൻ ചെയ്യിക്കും.
ഓക്കെ, ഐ നോ. അപ്പൊ ഇപ്പൊ എടുത്ത എത്ര ഇമേജ്, എത്ര സാമ്പിൾസ് എന്ന് ചോദിച്ചുള്ളൂ.
നമ്മൾ
10 ഡേറ്റയിൽ 7 സാമ്പിൾസ് അല്ലേ എടുക്കാൻ പറ്റുള്ളൂ.
നമ്മൾ 10 ഡാറ്റാ സെറ്റ്സ് ആണ് ഉപയോഗിച്ചത്. അതിന്റെ അകത്ത്
ഈച്ച് ഡേറ്റാ സെറ്റില് എത്ര സാമ്പിൾസ്?
ഒരു 100 അങ്ങനെയൊക്കെ ഉണ്ടാവും. അത് എല്ലാത്തിനും കറക്റ്റ് എണ്ണം അല്ല, എണ്ണം കുറച്ച് വ്യത്യാസമുണ്ട്.
ഈ ഒരു പ്രോഗ്രാമിൽ ഇതെല്ലാം വരുമല്ലോ, എന്നാലേ നമുക്ക് കാൽക്കുലേറ്റ് ചെയ്യാൻ പറ്റുള്ളൂ. ആക്യുറസി കാൽക്കുലേറ്റ് ചെയ്യണമെങ്കിൽ how many number of samples you are taken, how many number you are making training, how many testing, etc.
8,000 10,000 അങ്ങനെ എന്തോ ഉണ്ട് ഒരു ഡാറ്റാ സെറ്റില് 1000 ഇമേജസ്.
അല്ല അത് കറക്റ്റ് ഇല്ലാതെ പിന്നെ നിങ്ങൾ എങ്ങനെ അക്യുറസി എങ്ങനെ കിട്ടിയത്? അക്യുറസി നിങ്ങൾ മെൻഷൻ ചെയ്തല്ലോ സ്ലൈഡിൽ.
നിങ്ങൾ ഇതിന്റെ പ്രോഗ്രാം കമ്പൈൽ റൺ ചെയ്യുമ്പോൾ തന്നെ നിങ്ങൾക്ക് കാണാൻ സാധിക്കും എത്ര ഇമേജസ് കാര്യങ്ങൾ റൺ ചെയ്തു. അപ്പൊ അതൊന്ന് അതിന്റെ വീഡിയോ നിങ്ങൾ നോക്കിയിട്ടുണ്ടെങ്കിൽ നിങ്ങൾക്ക് മനസ്സിലാവും. നമ്മൾ എടുത്ത കോഡ് ഗിറ്റ്ഹബിൽ നിന്നാണെങ്കിൽ ഗിറ്റ്ഹബിലും അവിടെയൊക്കെ അത് എക്സ്പ്ലെയിൻ ചെയ്തിട്ടുണ്ട് അതിന്റെ ഡാറ്റാ സെറ്റ് ഡീറ്റെയിൽസും കാര്യങ്ങളും.
സർ നമ്മുടെ ഡാറ്റാ സെറ്റിൽ 43 സാമ്പിളാണ് ഉണ്ടായിരുന്നത്. അതിൽ 20 സാമ്പിളാണ് നമ്മൾ എടുത്തത്.
അല്ല ഞാൻ പറഞ്ഞ ഫ്രാക്ഷൻ 9284 ഫ്രാക്ഷൻ പറഞ്ഞെങ്കിൽ ഇറ്റ് റിക്വയർഡ് മിനിമം 100. മനസ്സിലായോ?
നമ്മൾ 20 സാമ്പിളിനെ വെച്ചിട്ടാണ് ചെയ്തത്.
അങ്ങനെയാണെങ്കിൽ 84 കിട്ടില്ല. മൾട്ടിപ്പിൾ ഓഫ് 2 അല്ലേ വരുള്ളൂ.
നമ്മൾ എടുത്ത സാമ്പിളിൽ തന്നെ ഇമേജ് ഓഗ്മെന്റേഷൻ വെച്ചിട്ട് ഒരുപാട് ആക്കിയിരുന്നത്. അപ്പം ഓരോ സാമ്പിളിലും
ഓഗ്മെന്റേഷൻ വെച്ച് ആക്കുമ്പോൾ തന്നെ അതാണ് ടോട്ടൽ നമ്പേഴ്സ്. ബേസ് യു ഹാവ് ടേക്കൺ 20, then ഓഗ്മെന്റേഷൻ കൊണ്ട് മൾട്ടിപ്പിൾസ് വരും. സോ ടോട്ടൽ സാമ്പിൾസ് നമുക്ക് അറിയണം. സോ ഓക്കെ, സോ ദെൻ എന്നാലേ നമുക്ക് അക്യുറസി എടുക്കാൻ പറ്റും. Any other questions?
ഓക്കെ, വെറുതെ അവസാനിപ്പിക്കല്ലോ. സർ എന്തെങ്കിലും ചോദിക്കാം?
ഇല്ല സർ. Okay, now.
Good evening. First of all, introducing myself, I am Adarsh, and our project topic is gesture-based home automation with health monitoring. Group members are Hridya, Danya, and Harida, and we are guided by Anas sir, Assistant Professor, ECE Department. The contents includes introduction, literature survey, problem identification, methodology, components description, work plan, conclusion, future scope, and reference. Generally, home appliances are controlled by IR remote, but here it is done more easily by our proposed system. Thus, the goal of our project is to design cost-effective and fully functional real-world product to control home appliances by simply hand gestures. And our project not only controlling of home appliances, but also monitor temperature and pulse of user. Here, gesture recognition means the process by which gestures made by user are used to convey information for device control. And also, it is improve the independency and quality of life of older users along with general users. We referred some papers and reached some conclusions. Presently, the technology readiness for smart home and health monitoring technology are still rare. In United States, 30% of those over 65 years, they would die than entering a nursing home. Nowadays, older people are considered burden for their relatives, and the healthcare units provided for their health facilities are of high cost. Cost effective of smart home and home-based technology still rare by the studies of economic assessment. And our literature shows there is a great demand of producing an effective home healthcare solution that monitor elderly people and in their home in real time. Conclusions to referred system, we finally find out that gestures are best modality by analyzing some modalities ENG, iris, and voice. In case of ENG, it's a weaker signal. It is difficult to extract, and also it has higher chance to interfere with other signal. Since its accuracy is very low and the easiness of use is high. Next, in case of iris, This methodology is very expensive. Thus, general public can't afford price. Even its accuracy is very high. The main drawback is that continuous use of this system may cause harmful to iris, and also easiness of use is medium. Uh, then in case of voice system, it's not completely hand free. They have to press button, and its accuracy is medium. Then it is very expensive since its useness is very high, and also it's very noisy. Then we selected our transistor. It has a low power consumption, simple hardware, and easy to operate and user friendly. Managing all of our home appliances from one place. It has high accuracy, medium user interface, and easiness of use also very high. Then now around the world, population are aging at an increasing rate due to our changing lifestyle. The proportion of persons are aged 60 will reach 2 billion by 2050. Since there is a growing concern about older adults can maintain their health and well-being while living in their home, and also they prefer to stay home rather than enter into a healthcare center. Thereby, there is a demand of cost-effective production, which help in reducing a burden for relatives. Usually, conventional wall switches are located in different corners of house, and this needs to manual operation to turn on and off. It became very difficulty for elderly or less able people. So we choose our transistor method as the best method to solve all these problems. Let's.
Next comes the design methodology. Here, ESP32 is the main controller, and the noted feature of ESP32 is that it have an inbuilt Wi-Fi module, and the other sensors used here are MPU6050, pulse sensor, and a temperature sensor. All these are powered using a battery. The temperature sensor and pulse sensor are used to provide an external healthcare monitoring in addition to the home automation. The temperature sensor using here is LM335. And the main MPU6050, it is basically a 6-axis motion tracking device. The gestures made by the user are captured and sensed by this module, and it undergoes further processing inside this module, and this data is fed into the controller. Similarly, the temperature sensor senses the temperature from the user and sends its value to the microcontroller. Pulse sensor measures the pulse rate and sends the value to the controller. And all these values from the controller are uploaded to the cloud. This forms the transmitter section. Now coming to the receiver section, we have another controller for receiving the signals from the transmitter, and also having several relays connected to several appliances. All these are powered by an external power supply. Here we have given an external access so that someone near the user, maybe a friend or a nearby user, can is able to see this health condition, that is the readings of the pulse and the temperature sensor. So here she will be able to continuously monitor the health condition of this user. Also, a buzzer is given so that we have set up a threshold value for the temperature and the pulse sensor, and if it exceeds beyond a certain limit, the buzzer starts to ring. And this is the proposed circuit diagram. Here we are using a battery, and a 7805 regulator is used in order to get a 5-volt constant DC output enabled, if it is used to enable the microcontroller. The pin number 19 and 20. 19 is connected to VCC and 20 is for ground. And other pins are connected to the sensors, and also MPU is enabled using a clock sensor. And in the case of temperature sensor, 3 is connected to ground and 1 for VCC, and an output is taken from the pin number 2. In the case of pulse sensor, that is VCC and ground is connected and the output is taken. In the receiver section, we are having a full wave rectifier in order to convert the external power supply into and the regulators are used in order to get DC and 12 volt DC, 5 volt DC for the controller and 12 volt DC which is used for the relays. The relays are connected to the pin number 8, 9 and 10 of the microcontroller, and pin number 19 is connected to VCC and 20 is grounded. And here we are using an external motor in order to turn or off the window. That is L293D, which operates based on the concept of H-bridge. Here the pins 4, 5, 13 and 12 are dedicated for ground. 8, 15 and 1 are connected to VCC. And here, as the phase and neutral are connected, as the signal arrives, the connection becomes closed and the relay 1 will be closed, and thus the corresponding appliance which is connected to the relay will be turned on or off. This is all about the receiver section.
Next is the hardware setup. Here in hardware setup, there includes our microcontroller, that is ESP32. It is a series of low cost, also low power, and also the main important factor is this. It has an integrated Wi-Fi and dual mode Bluetooth. Then the main processor is 32-bit microprocessor. Then the frequency used is up to 240 megahertz, and the Wi-Fi frequency ranges almost about 2.4 gigahertz. And the ADC pins are 18 channel, and DAC pins are, that is digital to analog pins are 2 channels. And the communication used is SPI.
Sir, hello sir.
Harita, continue. Kuഴപ്പമില്ല മറ്റേയുള്ള Harita, continue.
The communication protocols used are SPI, I2C, and UART. The digital input-output pins number is 32, in which the 34 are general purpose input-output pins. And the next is the MPU6050 sensor we are used. It is an integrated 6-axis motion tracking device. It consists of a 3-axis gyroscope, a 3-axis accelerometer. So we can track the motions of the user in the 3 directions. And its operating voltage is 2.375 up to 3.46 volt. And here also it uses the communication protocol I2C. Then the clock frequency is 32.7. Then the 6 integrated 16-bit ADC channels is used to sample each axis for 3/4 gyroscope and 3/4 accelerometer. And the next part is the gyroscope. It is usually used to measure the velocity of the motion in XYZ direction. Then the operating current is 3.6 milliampere. It also uses the 16-bit ADC on the sample each axis. Then the accelerometer. Accelerometer is to detect the orientation along the 3 axes. Then it is measured in the gravity force unit. Then the motion processing. Here we are using digital motion processing which supports 3D motion processing and compute gesture recognition algorithms in order to collect the data of the sensor while synchronizing the sampling at the user as a definite rate. Then the total data set includes 3-axis gyroscope, 3-axis accelerometer, and the processed data will be read by the DMP register. Then it's the L293D, that is a motor. It is a 16-pin IC. It generally consists of 2 motors. Here it is used in our project in order to control the action of a window so that it can move in both directions, any directions. And it works mainly on the concept of H-bridge. Then the enable pins are 1 and 9. Then the suitable frequency of this motor is 5 kilohertz. Then the temperature sensor ranges from minus 55 degrees Celsius to 150 degrees Celsius. And here we get the output voltage that is correspondingly to the temperature. In detail, we say that for every, there will be 10 millivolt for every in 1 degree rise of temperature, and the accuracy is 0.5 degrees Celsius and input is 5 volt. Then the pulse sensor, in order to measure the pulse of the user, here we are using, and its operating voltage is 5 volt, and the current consumption is 4 milliampere. Here, it has an inbuilt amplification and noise cancellation circuit. Then here we are using the relay in order to control the fan switch, light, and also window. Here we are using 4-channel relay, which is operating on 12 volt battery. Then we talk about the software setup. As we earlier mentioned that we told that in order to capture the gestures, we use the gloves which is connected to the sensor. So we get the status of the different sensors, and the data of this will be read by the sensor, and it will be given to the microcontroller at the transmitter side. From that, these data will be uploaded to the cloud. From this cloud, the data is given to the microcontroller at the receiver side. At the receiver side microcontroller, we are already given a threshold value for each sensor. That is, in the case of my MPU6050 sensor, if we move our hand towards the right, the light will be on. And if we move the hand towards right once more, the light will be off. Likewise, if we move our hand towards left, fan will be on, and when we move in the same direction, the fan get off. Likewise, we use top direction for window, and if same action happens, the window will be closed. Thus, accordingly, relay connected corresponding appliances will be controlled. Then coming to the pulse sensor, we have set the threshold values as 100 beats per minute, and so the incoming value, that is the output of the sensor, is getting exceeded than the 100 beats per minute, the buzzer gets on. And then the temperature sensor, in temperature sensor, the threshold we set is 37 degrees Celsius. So if the temperature of the patient is exceeded, the buzzer will be on. Thus we can get an alarm. And here we can see an external access, that is, we are providing a facility that an external can access the data which is uploaded in the cloud. And here we assume in our project, the external access is the hospital staff, maybe the personal doctor of the user or the staff related staff of the patient, etc. So while he can access the cloud data, he can monitor the patient continuously from the hospital itself. So he can do the needful to the patient. Then is the software part. Here we have used the Eagle software, that is for PCB designing, and majorly it consists of Eagle module, layout editor, and schematic editor. Then also we are using Proteus, that is for electronic automation and simulation, like that. And also we are using Arduino IDE, it is for programming, and here we use the C language for programming. And this is the simulation video of our transmitter section. And this is the simulation video of a receiver section. Here we can see the window is controlled by the motor, 2-direction motor LM35, and the light on off is shown by a bulb, and also fan is shown by with the help of the motor. The motor is getting rotated. And next is the PCB fabrication and layout. It involves first of all etching process, then drilling, then soldering, and testing and assembly. So while we designed the PCB initially, we have completed only till soldering. So for the PCB designing, we initially took a sheet of copper, then we printed the PCB layout that we wanted into a photo paper, and we just ironed the photo paper on that copper sheet. And in order for etching purpose, we dip the photo paper with the copper sheet in the ferric chloride solution, and also by washing, the unwanted materials are removed. And then for drilling, we have drilled drilled with the help of a machine. And this is the drilling we have done. This is the cutting of the copper. And the soldering also is completed only partially, then the remaining testing and assembling are still not completed. This is the final PCB layout of a transmitter section PCB. And this is the receiver PCB layout. And the total cost for the project components are almost 2,686 rupees. And coming to the conclusion, here a project provides an adequate method to control the home appliances by mere hand gesture by wearing a glove, which we have made. Then the home automation, healthcare monitoring, temperature and pulse sensing is also done along with this. We have proposed a very cost-effective, efficient, and fully functional real-world product. And also the implementation of this project will improve the independence and the quality of life for the older people as well as the other. Our main motto of our project is to help the elderly people to control the home appliances more easily without the help of the others. And the future scope includes all the home appliances will be combined to the single node and controlled by the single controller device. And the product we have designed will be very compact in size, and also it will be easy user friendly when it is wearable. Then the system can be also implemented in human computer interaction, since the gestures play a very important role. And in future we can use the RFID card, so we can use to identify the rooms, and hence the system can be implemented for multiple rooms. Then on adding a magnetometer or a barometer to our project, the degree of freedom can be increased, that is more hand gestures can be involved. Also by using I'm talking about the future scope, it can be involved in the robotics and sign language, games and other various applications. Thus we provide a effective smart home healthcare solution can monitor elderly people in the home and also in the real time. And these are the references we have gone through. Thank you.
Yes, I can. I'm here, okay. So fine. നിങ്ങളുടെ PCB നിങ്ങൾ റെഡിയാക്കി അല്ലേ? സോൾഡറിങ് ഇല്ല എന്നാണ് നിങ്ങളുടെ PCB വീഡിയോ ആണോ അത്? നമ്മളെ പ്രസന്റേഷന്
സിമുലേഷൻ വീഡിയോ ആണ്.
PCB ബാലമാഷിന്റെ ലാബില് അവിടെ ചെയ്തല്ലേ? ഓക്കെ.
നിങ്ങളുടെ ഇത് സോൾഡറിങ് കംപ്ലീറ്റഡ് അല്ല എന്നാ പറയുന്നത് അല്ലേ? ടെസ്റ്റിംഗ് ഇല്ല.
PCB റെഡിയാക്കിയിട്ട് സോൾഡറിങ് ചെയ്തിട്ടില്ല.
അപ്പോഴേക്കാണ് ഇത് വന്നത് സാർ. പ്രശ്നമൊന്നുമില്ല.
നിങ്ങളുടെ ഫീച്ചർ വർക്ക് എന്താണ് പറഞ്ഞത്?
നമുക്ക് സാർ ഇത് കൂടുതൽ RFID ടെക്നോളജി യൂസ് ചെയ്തിട്ട് നമുക്ക് ഇത് മൾട്ടിപ്പിൾ റൂംസിൽ ഇംപ്ലിമെന്റ് ചെയ്യാം. ദെൻ മാഗ്നറ്റോമീറ്ററും ബാരോമീറ്ററും ഇൻക്ലൂഡ് ചെയ്തിട്ട് നമ്പർ ഓഫ് ഹാൻഡ് ജസ്റ്റേഴ്സിന്റെ എണ്ണം നമുക്ക് കൂട്ടാൻ പറ്റും. ഡിഗ്രി ഓഫ് ഫ്രീഡം കൂട്ടിയിട്ട് ഒരുപാട് ഹാൻഡ് ജസ്റ്റേഴ്സ് നമുക്ക് ഇൻവോൾവ് ചെയ്തിട്ട് കൺട്രോൾ ചെയ്യാൻ പറ്റും കൂടുതൽ അപ്ലയൻസസ്.
പിന്നെ ഹാൻഡ് ജസ്റ്റേഴ്സ് മാത്രമല്ല, ഞങ്ങൾ ടെമ്പറേച്ചറും പൾസും കൂടി ഹെൽത്ത് മോണിറ്ററിംഗ് കൂടി നടത്തുന്നുണ്ട്.
1D ആണോ? ഹാൻഡ് ജസ്റ്റേഴ്സ് 1D ആണോ?
അല്ല സാർ, ഒരു ഗ്ലൗ ആണ്, അതിൽ സെൻസേഴ്സ് വെച്ചിട്ട് അങ്ങനെയാ ചെയ്യുന്നത്.
നമ്മള് സെൻസർ യൂസ് ചെയ്യുന്നതിൽ ഗൈറോസ്കോപ്പും ആക്സിലറോമീറ്ററും അപ്പൊ 3 ഡയറക്ഷൻ.
Depending on the motion of the gyro, നിങ്ങൾ ജസ്റ്റ് ഐഡന്റിഫൈ ചെയ്യുന്നു അല്ലേ?
അതെ സർ.
ആക്ച്വലി ഇവർ യൂസ് ചെയ്യുന്ന MPU അല്ലേ? MPU കോമ്പിനേഷൻ ഓഫ് ഗൈറോ ആൻഡ് ആക്സിലറോ, അത് കോമ്പിനേഷൻ അല്ലേ? ഓക്കെ. ഇനി മാഗ്നറ്റോമീറ്റർ ആഡ് ചെയ്തപ്പോഴത്തേക്കും നമുക്ക് കുറച്ചും കൂടി എക്സ്ട്രാ ജസ്റ്റേഴ്സ് ക്യാപ്ചർ ചെയ്യാൻ പറ്റും. അപ്പൊ അതിന്റെ വാല്യൂസും കൂടി നിങ്ങൾക്ക് വേറെ ഏതെങ്കിലും ആക്ടിവിറ്റിക്ക് ആഡ് ചെയ്യാൻ പറ്റും അല്ലേ?
കുറച്ചും കൂടി മോഷൻസ് നമുക്ക് ക്യാപ്ചർ ചെയ്തെടുക്കാൻ പറ്റും.
ആ മോഷൻസ് വെച്ച് കുറച്ചുകൂടി ഫങ്ഷൻസ് എക്സ്ട്രാ ചെയ്യാൻ പറ്റും. എന്തായാലും അപ്പൊ നിങ്ങൾ PCB ലേഔട്ട് ഒക്കെ വരച്ചത് ഏതിലായിരുന്നു? അൾട്ടി ബോർഡ് ആണോ അതോ ഏത് ഈഗിൾ കാഡ് ആണോ? അതോ നിങ്ങൾ PCB തന്നെ പ്രോട്ടീസിൽ തന്നെ PCB മേക്ക് ചെയ്തോ ഈ സർക്യൂട്ട് സിമുലേറ്റ് ചെയ്തിട്ട്?
ഈഗിളിന്റെ ഇതില് കോമ്പണൻസിനെ സെറ്റ് ചെയ്തിട്ട്
ഈഗിൾ കാർഡിലാണ് ചെയ്തത്.
അറേഞ്ച് ചെയ്ത് പിന്നെ അതിനെ
അപ്പോൾ നിങ്ങളുടെ പ്രസന്റേഷനിൽ ഇപ്പോൾ ലിറ്ററേച്ചർ സർവേ ഈ പറഞ്ഞ കമ്പോണൻസിന്റെ സ്പെസിഫിക്കേഷൻസ്, വർക്കിംഗ്, PCB ലേഔട്ട്, പ്രിന്റിംഗ് എല്ലാം ഉണ്ടല്ലേ?
താങ്ക് യു സർ.
ഓക്കെ.